Today I will be talking to you about migraines and why they're a cellular communication disorder. Okay, so to understand why migraines are a cellular communication disorder, you have to understand how cellular communication works. So cellular communication is a process where cells receive a message from another one, and there are two different types. There's local and long distance signaling. Now, in both of these processes, a ligand bonds to a receptor, which starts messages throughout the process. There are three stages. There's reception, transduction, and response. Reception is where the ligand is sent out after receiving a signal to move. Transduction is where the ligand bonds to the receptor, and response is where the receptor starts a process, such as cell death, cell split, or another chemical process. Now, why migraines are a cell communication disorder is because excited brain cells pass through gap junctions through local signaling through the trigeminal cervical complex and activate an overproduction of hormones or neurotransmitters. These messengers travel through the bloodstream to the trigeminal nerve, and they're overly excited, so it causes a chain reaction upon the reception process. The reaction will release high amounts of serotonin, histamine, bradykinin, and prostaglandin, if that's how you say it. And these chemicals released can cause sensitization, and there are two types of sensitization, but one cannot occur without the other. Peripheral sensitization begins with the release of more overstimulated brain cells because they are not modulated. They should be modulated by serotonin, however, this can't occur because there is a too extreme concentration of the hormones or neurotransmitters. So the CAMP-PKA cascade, or protein kinase cascade, is thought to be one cause of the sensitization because it activates an overproduction instead of controlling the release and constricting the amount that is let out. Now, CSD, or cortical spreading depression, is thought to be connected to migraines because MRI imaging shows that the cerebral blood flow is the same whenever a CSD attack occurs and a migraine occurs. And the waves in CSD release chemicals that cause the same sensitization that occurs in migraines. The chemicals that are released overall in all these processes cause sensitization of trigeminal neurons, which cause sensory signals to travel to the brain. And this initiates pain in the trigeminal cervical complex and begins the peripheral and central sensitization. Now, whenever the chemicals are released, it sends to the trigeminal cervical complex, and it causes blood vessels to dilate and thus causes pain perception because it occurs on the same area that causes pain, which is located behind your nose. And here's an image of what central sensitization looks like. When the neuron is sensitized, it then causes pain, throbbing, and allodynia, which I'll explain in the symptoms. And when it's not sensitized, you don't have any pain. Now, genetics. It can be passed through genes. There's a 50 to 70% chance, and it's only with familial migraines. There is the CACNA1A, ATP1A2, SCN1A, and PRRT2 genes. The only one that I could find information on was the CACNA1A, and it's located on chromosome 19 at locus 11q24, which would be about in the middle of chromosome 19. Now, there are environmental factors that can cause migraines as well. This would be your sporadic migraines, and it can be climate change, whether the temperature drops or increases over a short period of time. Barometric pressure, which a lot of us get headaches normally because it causes pressure in your ears. Stress, anxiety, depression. If you get really stressed out about something, it'll cause an over-release of more serotonin. Lack of sleep and change in eating habits or diet. You need to keep your body regulated on what you consume. And if you don't consume the right amount, it'll cause a migraine. Now, there are a lot of symptoms, and there are different types of migraines that have specific symptoms to those. Now, you have your basic migraines, which don't occur with aura, and it would be nausea, vomiting, sensitivity to light, sounds, or smells, dizziness, vertigo, or the throbbing on one side of the head. Now, our specific symptoms, these are rare, but visual, you can have floaters, you can have blind spots in your vision, you can have things that look like zigzags. And then sensory is the rarest type. It only occurs with hemiplegic migraines, and it causes tingling and numbness in one side of your body or your face, lips, tongue, tongue, and it causes weakness and dysphagia. Now, there are also symptoms specific to the different sensitization processes. There's peripheral, which causes hearing loss, tinnitus, and oral fullness, and central, which causes allodynia that I had mentioned. Allodynia is pain whenever you brush your hair, wear contacts, wear glasses, or even wear earrings, and breathe in cold air. Now, to know if a migraine is going to occur, there are premonitory symptoms that can occur up to 48 hours before an attack will occur, and that would be fatigue or sudden bursts of energy, frequent urination, and yawning. And then after a migraine has completed its course, which can take 4 to 72 hours, it can leave a lingering headache or a bruised feeling. And a lot of people end up having to go to the hospital if a migraine does not subside within 72 hours, because that is a sign that something serious is happening. Now, there's no known cure for migraines as of right now. According to NCBI, I could not find any known cure. But there are acute treatments that you can use. There's Botox, which will block the signals and cause numbness and temporary paralysis of the muscles. There are triptans, which will block serotonin receptors. Cephaly is a headband that you can wear around your head, and it will send electrical signals to stop a migraine before it progresses. And SPG is an injection that is injected into the trigeminal nerve behind your nose that'll stop the progression. And there are also anti-inflammatories like ibuprofen, Advil, that'll stop inflammation and stop dilation of blood vessels. There are also preventatives, which you can take supplements, beta blockers, and anticonvulsants. I take supplements such as riboflavin because it reduces the frequency that you will have a migraine and the severity of a migraine if you have one. Go! It's not wanting to work. Hello? Okay, well, I'll just keep going anyway. Alright, so there is a chance of remission. Nobody dies from migraine unless it's like really, really severe and something else happens. But there is no known cure. About 84% of people who have migraines never lose them over their lifetime. They'll have them, but not as frequent. Only 10% receive full remission, and so they will never have a migraine after a few years of treatment. About 3% will have partial remission, so they'll have them maybe a few years apart, and then 3% have chronic migraines for the rest of their life. And something interesting, the reason that I chose this is because this summer I was in the hospital because they thought that I had a brain tumor, and so we called MD Anderson, and I got MRI done, spinal tap, all that kind of stuff, and they diagnosed me with hemiplegic migraines. So this is the rare one. This half of my body goes numb, like my arm and my face, and so it freaked me out the first time it happened because I was like, am I having a stroke? That kind of thing. So it was a hard diagnosis, and they had to give me, it was a migraine cocktail. It was like Benadryl, a bunch of different anti-inflammatories to calm it down, but it's really hard to diagnose migraines because they think it's brain tumor. So it takes a while to diagnose, and that's all I got.